Hi everyone, welcome back to another Prolver video. It's been a while. So, I've always had this question. How the fuck did they find E? Like, I know that it's 2.71828 something, but how the fuck do they know that? I also know that it's the base of the function whose derivative is itself. Okay, that's cool, but how the fuck did they get the number? That's like saying a treasure exists without giving me a map. So today I wanted to walk through how you yourself could have discovered E and what the number truly is. I want you to take a step back, and you're coming off the turn of the century where some virgin in the 1600s has just discovered derivatives. And you think to yourself, okay, this is pretty cool. I wonder if there's a function whose derivative is itself. Let's try some things. Let's try any polynomial, so x to the a, and we quickly see it fail. As the exponent on the x is decreased by 1, they're no longer the same. We can then try some trigonometric functions like sine of x, but we see that its derivative is cosine of x. Similarly, the derivative of cosine of x is negative sine x. So we don't have our function yet. Okay, so we've tried a couple functions and we're kind of stuck. Let's try a new one that we haven't tried yet. A to the power of x. So let's first differentiate a to the power of x, which we can do so with the derivative formula. So we'll first input in as our function a of x. For fx plus h, we'll put in ax plus h. And for f of x, we'll just put in a to the power of x. We can bring that a to the h down, and then we can factor out by a to the x. And then one cool thing here is that since a to the x does not depend on h, as h is in the limit, we can actually bring a to the x outside of that limit. But whoa, something cool has happened here. The derivative of a to the x is a to the x times some constant. Let's call this constant m of a. This is a good step. It's not a function that's derivative is itself, but it's at least proportional, or itself times a constant. Keep in mind here, as a is our base, m of a is also a constant, as a is a constant. A isn't changing like x is. Think about what that means for a sec. For this function, a to the x, if I go from x to x plus 1, I know my rate of change has increased by a factor of a. If I go this
from
is cool and all, but I asked for a
a3,
function
I know my
whose
rate of
derivative
change
is
has
itself,
increased by
which
a
means
again.
we need to set m
The rate at
of
which
a
this thing grows
equal to
is
1.
baked
That way we
into
get the
function
derivative of a
itself.
to the x is equal to 1 times a to the x, which is equal to a to the x. Okay, so we remember m to the a being this limit where h approaches 0 and a is some constant. And we want to set m to the a equal to 1. So let's try some different a values and see what we get for m of that value. So m of 1 gets us 0, that's not very helpful. M of 2 gets us 0.7, which is a bit smaller than 1, so our derivative will get shrunk. And a to the 3 will get us a bit over 1, so our derivative will get stretched or increased. Okay, we're getting closer. We know our a is somewhere between 2 and 3. And we could just try different numbers between 2 and 3, but I'm personally a caveman and I don't like using computers, so I'm going to do this one by hand. Where do I get started? So we know that we have this limit and we want to set it equal to 1. Again, this is our m of a. Okay, so let's solve for this bitch. Let's first get rid of the limit, and we just know that for some really small m, this m of a, or the thing on the left, will be really close to 1. We can multiply both sides by h to bring the h over. We can then add that 1 over to get a to the h is roughly equal to 1 plus h. We can then take the h root of both sides, or if you can think about it like exponentiating to the power of 1 over h. This will cancel out on the left side to give us a is roughly equal to 1 plus h to the power of 1 over h. And holy shit, this is our number. This is e. So when a is equal to this number, m of a equals 1. That is so cool. We can also rewrite this as h is equal to 1 over n for some n that is approaching infinity. This is the same number, it's just written in a different way that some people like to use. And this is the exact definition of A, or in this case, E. Now, I know what you're thinking. This is not a fucking number. This is a limit, this is some letters. There's only one number here and it's 1. What the fuck are you talking about? Well, you can kind of think of this as like a recipe to make E. E is what's called a transcendental number, which means it's an infinitely long number on top of other things. So what this is telling us is if we get n to be really, really large, this limit will give us a recipe for the true number of E, which comes up to about 2.71828. And just like that, we've done it. The function, which is a derivative of itself, is the function which is base e to the power of x. I hope you guys enjoyed. It's been a while since I've made one of these, and I'm also really feverish. But check out some of the videos that are like from 2 years ago. And like and subscribe.